Why small specialized models matter. The last decade of AI has been shaped by a simple idea. Bigger models are better. More parameters, more data, more capability. And for a long time, that was true. Scale unlocked breakthroughs we didn't expect. But the next decade won't be defined by size. It will be defined by fit, by models that are built for a purpose, not for a leaderboard. Small, specialized models are becoming the quiet backbone of modern AI, not because they're replacing large models, but because they're doing something different. They're making intelligence practical, they're making it efficient, and they're making it possible to put capable systems into places where a giant model simply doesn't belong. To understand why this shift matters, it helps to look at how intelligence is actually used. Most real-world tasks don't need a model that knows everything. They need a model that knows one thing well. A medical imaging model doesn't need to write poetry. A warehouse navigation model doesn't need to solve equations. A fraud detection model doesn't need to generate stories. They need precision, reliability, and speed, not generality. Large models are extraordinary at reasoning across domains, but they're expensive to run and slow to deploy. Small models are the opposite. They're fast. They're efficient. They can run on devices, not just in data centers. And because they're trained for a narrow purpose, they often outperform larger models on the specific tasks they're designed for. Imagine a system that monitors air quality in a city. A giant model could analyze the data, but it would be wasteful. A small model trained specifically to detect patterns in particulate matter can run continuously on low-power hardware, respond instantly, and operate without a constant connection to the cloud. It doesn't need to be general. It needs to be right. This is the pattern emerging across industries. In finance, small models detect anomalies in transaction streams in real time. In manufacturing, they monitor vibrations in machinery to predict failures before they happen. In healthcare, they analyze scans, signals, and biomarkers with a level of focus that a general model doesn't naturally have. And in robotics, small models handle perception, control, and safety, the parts of the system that need to be fast, predictable, and grounded in the physical world. What makes this shift even more important is how these models interact with agents. An agent doesn't need one giant model to do everything. It needs a collection of specialized models it can call on when the task demands it. A navigation model for movement, a vision model for perception, a domain-specific model for analysis, or a reasoning model for planning. The agent becomes the conductor, and the models become the instruments. This architecture, many small models coordinated by a planning system, is more flexible than relying on a single large model. It's easier to update, easier to audit, easier to deploy. And it mirrors how complex systems work in the real world, not as one monolithic intelligence, but as many specialized components working together. There's also a practical reason this matters. Running a large model for every task is expensive. It consumes energy, bandwidth, and hardware. Small models reduce that cost dramatically. They make AI accessible to organizations that can't afford massive infrastructure. They make it possible to run intelligence on devices at the edge, in hospitals, factories, vehicles, and homes, without sending everything back to the cloud. And they make AI safer. A small model trained for a narrow purpose is easier to test and easier to constrain. It's less likely to behave unpredictably because its world is smaller. Its job is clearer. Its boundaries are tighter. In high-stakes environments, that matters. None of this means large models are going away. They'll remain the foundation for reasoning, planning, and general understanding. But the future isn't a competition between big and small. It's a collaboration. Large models provide the broad intelligence. Small models provide the precision. Agents provide the structure that ties them together. This is the quiet shift happening beneath the surface of AI. Not a race toward ever larger systems, but a move toward architectures that are modular, efficient, and grounded in real-world constraints. Intelligence that fits the task, not the other way around. And this shift leads naturally to the next question. If small models are becoming essential, how do they connect to the systems that see, hear, and interact with the world? That takes us to the next part of the sequence and the next episode, the rise of multimodal systems and why integration is becoming more important than scale. If you enjoyed this video, consider subscribing for the next episode and to learn more.